This is Josh White with JW Math Tutoring. In this video, I'm going to go through Digital SAT Linear Paper Practice Test number 6, the math section, specifically the unique questions that do not appear on any of the Bluebook practice tests. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Just before I begin going through these unique questions from Linear Non-Adaptive Paper Practice Test number 6, please keep the following things in mind. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, as I mentioned in the intro, these are the problems from Linear Non-Adaptive Paper Practice Test 6, which are unique to that test. And what I mean by that is, these are the questions that do not appear on any other Bluebook practice test. Okay, so the point is, going through these questions will not ruin or spoil any of the Bluebook practice tests. These are basically additional questions to complete, in addition to those, for more practice. And lastly, there is a PDF that'll be in the description and also in the pinned comment where you can download basically a copy of these questions. All right, so that being said, starting off question number 2. We have a scatter plot here, relationship between two variables, and we want to know which of these graphs basically shows the most appropriate model. Okay, so if you notice these, first of all, as the x increases, the y also increases, so we can get rid of this one right away. And you can see that, the increase is pretty slow at the beginning, but then it picks up towards the end, so D is just going to be the correct answer here. All right, next up, we have question number 5. Let me just zoom in here. Okay, so here you have an object that's being launched upward into the air, and then it, falls back down to ground. So during which of these intervals was the height of the object increasing? So it's basically, notice it's going to be from 0 to 2. The height starts off at 10, it goes up, 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 reaches its maximum here at 2 seconds, and then it is decreasing until it hits the ground at 4 point whatever seconds. So the correct answer to this is just letter A, from x equals 0 to x equals 2. Next up is question number 6. It's a basic unit conversion. We're going from 1,116 inches to yards, and they give you the conversion here, which is that 36 inches is equal to 1 yard. So all you're doing here is really just dividing 1116 by 36. The inches cancel out, and the correct answer for this is going to be 31 yards. So 31 is what you would type in, or fill in for this question. Next up, number 8. Here we have a linear function. They tell you that when x is 0, f of x, i.e. y, is 30. Okay, so that means this this function goes through the point 0, 30. What's the value of b? Well, b is the y-intercept, which you should know is the y value when x is equal to 0. So they literally just gave this to us right here. Correct answer for this is D. Now, of course, you could go to Desmos, and you could just go ahead and you could do a table, and you could put in the point that you're given, and then you could do linear regression. The equation is just x plus b, and then it just tells you right here b is 30. Okay, so that's how you could do this in Desmos if you didn't recognize that, this is the y-intercept. Next up, question number 9. Here you have an exponential function, and they want to know, what does p of 0 equals 1800 mean? What basically you interpret, this right here, which this is really a point. It's really 0, 1800. All right. So notice 0 here stands for t. Okay, so t equals 0. That means when the study is beginning, i.e. 0 years since the study began. All right, so 1800 then is your output, which tells us that this function gives the estimated number of marine mammals. So that means there are 1800 marine mammals when this study first began. Okay, so the correct answer for this is just going to be right here, letter B. Number of marine mammals, 1800, when the study began. All right, next up, number 9. Here you have basically a frequency table. excuse me, 19, not 9. Here you have a frequency table. I want to know which of the following could be the median number of employees for restaurants in this town. Okay, so the easiest way to find the median value in a frequency table is to first figure out like what number value is the median. So the way I like to do that is I take 17, I divide it by 2, that's 8.5. Since this is a decimal, I round it up to the next number, which would be 9. Therefore, the ninth value is your median value if you started counting. So now we're just going to add down the frequency column, which is the number of restaurants column. So for example, 2 in this group plus 4 in this makes 6 total. Then I add 2 more, that means I have 8 total. Notice I haven't reached 9 yet. Then I add 7 more and I get 15. That means the ninth value will be in this group right here. So the only possible answer is a number that's between 20 and 25. Okay, so that has to be letter D, 21 as the correct answer. Next up, question number 22. Here we have one that deals with percentages. So, easiest way to do these, I think, is the strategy of picking numbers. So I'm going to start with 2007 as, say, earning $100. Okay? When you have these percentages problems, almost always you want to start with 100 as the original amount. Okay, so then in 2008, he earned 14% more than 2007. So that would just be basically 100 plus 0.14 times 100. Well, that's just 14. That's why I chose 100 to start with. So the total earnings in 2008, 114. Okay, now 2009, it's 4% more than 2008. So now we're taking 114 and we're doing plus 4% of the 114. Now this, we can just go to Desmos, and I'll just tell you it's going to be 118.56. This is, I believe, going to be 4.56. Let me just double check that just to make sure. Slide this over. Clears up. Yep, 118.56. Okay. So now, if Xena earned y times as much in 2009 as 2007, what is the value of y? Okay, so basically what we're saying is 2007 times y times as much, is equal to 2009. So 100 times y is equal to 118.56. So this thing is just 118.56 divided by 100, or really you just move the decimal point over 2 places and get 1.1856. So the correct answer is just going to be letter D, and that's it. And again, that's why I like to choose 100, because once you get to the last step, you should be able to realize that it's just going to be, the decimal point moved over 2 spots. Next up, question number 24, we have a basic trig problem here. What is the value of tangent A? So for this problem, you probably notice this has to be 60 because this is 90, this is 30, that's 120 total. 180 minus 120 leaves you with a 60. 30, 60, 90 triangle. Now, first I will show you, if you know the 30, 60, 90 triangle formulas, then you know that the short side, which is the side across from the 30, is half the hypotenuse. So this side has to be 27, okay? Because again, it is 1/2 of 54. And then down here for the side opposite the 60, which I call the long leg, that's just the short leg times root 3. So this will be 27 root 3. So now tangent of A is equal to, let's see here, opposite, which is 27 root 3, over adjacent, which is just 27. Therefore, 27 cancels out, and we just get root 3. So the correct answer for this problem is just letter C. Now, you technically wouldn't even need to figure out the side lengths if you recognize this is a 30, 60, 90 triangle, because the basic ratios that you see, for example, the ratio between the sides, it's like typically you see this is 1, this is 2, this is root 3. So like the tangent of a side opposite a 60-degree angle is always going to be just equal to root 3 over 1 or root 3. You know what I mean? It doesn't matter. Like here they have 27s in front, but that part doesn't matter because they cancel out. So you technically don't need to find these side lengths in order to do this one. I will also show you, you could do this one in Desmos as well. If you do not know the special right triangle formulas, like if you don't remember them, basically what I would do is I would note that, okay, we want to know the tangent of angle A, right? So basically we're going to find these two sides just by doing Pythagorean theorem and by doing another trig function. So I would start with, let's say, sine 60 equals opposite. So this is BC over hypotenuse 54. Okay, so I go to Desmos and BC is going to equal, actually I'm just going to call it B. Actually, no, I'm going to call it little a because that's how we can, it's opposite angle A, so we can just call it little a. All right, so that's equal to 54 times sine of 60. Now notice this is giving me a negative number. That's most likely because this is in radians. I want it in degrees, so just click the little wrench, switch to degrees if you're not already there. Okay, so that's little a. Now for the side opposite angle B, the side opposite to 30, like let's call this little b, that's just going to be the cosine. Cosine 60 equals BC, sorry, not BC, it's AC, the side we're trying to find, the adjacent, over hypotenuse, 54. So now we can just say B equals 54 times cos 60. Okay, notice gives me 27. All right, so now I have all the sides. So now tan A is equal to opposite over adjacent. So all you have to, so basically it's going to be equal to B over A. The opposite side, excuse me, A over B. The opposite side here is A, the adjacent side is B. So tan 60 equals A over B. So all we have to do is go to calculator here and do A divided by B. And then you just go through these answer choices and you see which one that's equal to. So is this equal to square root 3 divided by 54? Answer choice A, no. Is it equal to 1 divided by square root 3? No. Is it equal to, whoops, square root 3? Yes. Notice we get the same exact answer. So this is a longer way to do it, obviously, but this is how you could do it if you do not remember the special right triangle formulas, but you do know how to do just basic trig to find the lengths of these sides, and then notice that tan A will just equal the opposite side length divided by the adjacent side length. All right, next up, let's look at number 25. So for this one, here they're talking about something increasing by 190%. They want to know which of these equations represents this model. So the thing to keep in mind is a 190% increase will actually be equivalent to something being 2.9 times greater. 2.9 times the original. And the reason is because it's like, let's say you start off with whatever, 1, right? That's the original. And then you increase that by 190%. So 190% as a decimal is 1.9. So you would take 1.9, multiply it by 1. So it's like you have the original, and then this is the increase. So after the increase, you would end up at 2.9. And how do you get there? Basically, it's the same as multiplying 1 by 2.9. So the correct answer for this one is going to be letter D. And again, if you think about it, if you think about the way an exponential function is set up, it's like the general form is like 1, a plus or a times 1 plus or minus r, like to the t. R is like your growth rate or your decline or decay rate, right? In this case, it's 190%. But you convert it to a decimal, which is 1.9. So that's where, notice it's the same exact work, it's the same thing, it works. That's why it simplifies to 2.9, and the correct answer is letter D. Next up, we have question number 27. Here we have a situation where we have a right triangle, ABC, Okay, C is the right angle, so we'll put B here, we'll put A here. BC is 162. Point D on side AB is connected, so let's just put D here, by line segment with point E on side, sorry, D is on AB, I drew this backwards. E is going to be over here on AC. Just check my notes. Yep, okay. Such that DE is parallel to BC. Okay, so these two line segments are parallel. Okay, and CE equals 2AE. So in other words, if like this is X, this is 2X. Okay, here's the whole trick to this problem. If you look at the small triangle on the top, A, E, D, okay? This side is X. If you look at the large triangle, A, B, C, okay? Notice this side here, AC, is not 2x. 2x is only this little part of it. The whole thing, you have to add the two parts in 3x. What that means is the large triangle is 3 times the size for each leg. The scale factor, each side length is 3 times that of the small triangle. So really what that basically says is like, the ratio of AE to AC, X to 3X, would be the same as the ratio of like DE to 162. In other words, DE is just going to end up being 162 divided by 3. Because what's going to happen here is like the X's will cancel out. You just have like 1 over 3, and then you get 3 DE. If you cross multiply, equals 162 divided by 3 divided by 3. DE should be equal to 54. That's what you would grid in. So again, you're multiplying by 3 go from small to large. So just what's the value you multiply by 3 to get a 162? If you don't know, you just divide 162 by 3 and get 54. And that's the correct answer to this one. Now let's take a look at the unique questions from module number 2. So starting with question number 9. Here we know that the ratio of these two line segments is 6 to 1. So XY, ZV, 6 to 1. And XY is 102. So put that on the top of our proportion. What is ZV? Well, we don't know. Therefore, we can just cross multiply this. 6x equals 102. X is going to equal 17. So the correct answer for this one is letter A. Let's look at 14 next. Here we have a rectangle. So we know its area is 155. And we know that the length is 4 inches less than, so we're going to subtract 4, 7 times the width. So let's use W for the width. What is the width in inches? So basically, you're multiplying the length and width together, setting it equal to 155, and then going to get your answer, basically for W. Now, just to save time, I'm just going to go straight to Desmos. I'm just going to type this equation in. So here's a couple things. First, if I want to just use W, then I'm going to use regression. And notice it gives me exactly W equals 5. That's it. That's my answer. That's what you would fill in. If you are not familiar with regression or don't want to use regression, you want to use an equation, then you do have to change everything, say, to X or to Y. And if you change it to X, you look for the vertical line. And notice there's one right here at positive 5. We ignore the negative 4 point, whatever, because, well, that doesn't give us, we don't have negative dimensions. So that's how you could solve the equation that you set up in Desmos. All right, next up, let's look at number 15. Very easy problem. What is the median of this data set? So the thing is, these numbers are not in order, so technically you really need to take them and put them in order, which is going to be 4, 4, 4, 5, 5, 6, 10, 18. Okay. Now, the way I like to do this, when it's a small set of this, is to start at each end and cross them off until you're left with either 1 or 2 values in the middle. Okay? So notice here we have 2 values in the middle. Technically, the median will be the average of these two, but they're the same number. So the median is just going to be 5. Okay? So the correct answer for this one is just letter B. Now, of course, we could go to Desmos, and I will show you how we could type the whole thing in. Let me just erase these numbers so I can view them clearly. So we're just going to do the median, and here we do not need to rearrange them. We can just type them in exactly as they are given. Right there, 4, 10, 18, 4, 4, 5, 6, 5. Correct answer is 5, and we can move on to the next problem. Next up, question number 16. Here you have a cylinder. We have its volume. We have the area of the base. What is the height? So, formula for volume of cylinder is just pi r squared h. Basically, this right here is just the area of the base, and then you multiply it by the height. So really, we're just plugging in here 432 for volume. The area of the base is just this pi r squared, so you just plug it in 24, and then you just multiply by h. So the correct answer is just 432 divided by 24. That's 18. You can do it in Desmos if you don't know it. Correct answer for this is just letter A. That's it. Let's look next at number 18. Here you have this line K, and then line J is perpendicular to it. So notice the slope for line K will be 7 because that is the m value, y equals mx plus b. So the slope of line J is going to be the opposite reciprocal of that. So that means we take the 7, we flip it to the bottom, and then since this is positive, we make it negative. So it's just going to be negative 1/7. Correct answer is letter B. Next up, let's look at number 20. Here we have we have radical, we have some exponents, and basically an equation. What's the value of C? Okay, so what's going on here is you have 4 to the 8c equals cube root of 4 to the 7th. What they want you to do, or the traditional way to do this, would be to first rewrite the right side as a rational exponent, which would be 4 to the 7/3. Then you just set these two equal to each other. Divide by 8, divide by 8. C is going to equal 7 over 24. Okay, so you could grid in this. You could grid in 0.2196 or 0.2197 if you wanted to round it. All three would be acceptable. Of course, we can just go straight to Desmos and solve this in there as well. So basically, if you just go to Desmos, we are going to use regression. So we're just going to type in exactly what we see, but just replace the equal sign with a tilde. We can get a cube root and then 4 to the 7th. Not r to the 7th. There we go. Okay, so now we have the value of c. You could enter the decimal. Here again, you see the 0.29. I wrote it wrong. Just reading my handwriting wrong here. It should be 0.2916 or 0.2917. Or notice if you just type C here, okay, here it gives you this, but if you click this, there you can get the fraction form. Okay, so if you want to be safe and enter the fraction form, that's how you can get it. Okay, so again, either of these answers, 7/24, 0.2916, 0.2917. Those are all acceptable correct answers for this problem. All right, let's look at number 27. So this problem, you have a system of equations. They tell you that the system has no solution. The easiest way, there's two different ways you could solve this. I'll show you both methods. Okay. What I think, honestly, is the quickest or easiest way is to put both of them in standard form. So that would mean that one on the top, you're going to subtract 48y. That's going to make it minus 112y equals 24. And on the bottom, you're going to add 12x. So that's going to make 12x plus ry equals negative or 1/8. Now, when a system of linear equations is no solution, the multipliers for the x and the y terms are the same number, but the number on the right is different. The numbers on the right, the multiplier is different. So notice, for the x terms, the multiplier is positive 4. So you do 12 times 4 is 48. So for the y's, it has to be the same. What that means is you take r, you multiply it by 4, and it must equal negative 112. Okay? So in other words, you just divide this and you get r equal to negative 28. So that's the correct answer. I think this is the fastest, quickest way, but I'll show you the way that I think a lot of people would actually do it is to put both in slope-intercept form and then compare the slopes. So if you wanted to do that, what we're going to do with the top one is I'm still going to subtract the 48y and get negative 112y, but I'm also going to subtract 48x and get equal to negative 48x plus 24. Then I'm going to divide by negative 112. Okay, so let's just jump to Desmos to get those simplified fractions. Negative 48 divided by negative 112. Okay, let's see what this is. Okay, it's 3/7. So y equals 3/7 x plus, I don't know what 24 over 112 is, 3/14. And it's going to be negative, but that part really doesn't matter. Okay, then for the bottom one, all you have to do is technically divide everything by r. So y equals negative 12 over rx plus 1 over 8r. So now you set these two slopes equal. 3 over 7 equals negative 12 over r. So cross multiply, 3r equals negative 84, divide by 3, r equals negative 28. So notice we got the exact same answer. It's a little more work, but if you want to do it this way, again, totally fine, totally acceptable. All right, so I hope you enjoyed these solutions to this linear paper practice test number 6, the unique questions on the two math modules, again, that do not appear in any of the Bluebook practice tests. If you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods, please do feel free to leave them below. Of course, check out the videos to the other unique questions from the other, linear paper practice tests. And always, of course, if you are looking to improve your knowledge of Desmos, please do check out my Ultimate Desmos Guide to Digital SAT Math. Over 3.5 hours of tips, tricks, instruction, and 45 practice problems to help you master Desmos for the digital SAT math section.